those of you in Zoom, let me know if something changes and you can't hear me anymore. Okay, so they gave me these 3 objectives that they were hoping that I could manage for them. The habitat model that covers the whole state. They want to understand what quality forests are, and then they were very interested in corridors between populations. And so we're going to start by covering the habitat model. And keep in mind, this is a huge project that spanned almost 3 years. We're going into the 4th year, so I'm not going to cover absolutely everything. I'm going to point out to you that Florida, longitudinally and latitudinally, is incredibly diverse, which makes building any kind of model that spans an entire state very difficult. Because bears in the Panhandle use habitat that's very different than bears near the Everglades. And the habitats themselves and variables you have to consider are essentially incredibly different across the entire landscape, yet we're going to try and model the state. This is a range map from 2005 from Stephanie Simic on the right. So the original range for these black bears were throughout the entire state. You can see it was much reduced by 2005. They were listed as a state threatened species. But one of the impetus of Florida coming and saying, hey, we need to know where bears could be, is that their bear population is growing. And in fact, a 2018 range map from the state showed you that we're seeing, especially in the Panhandle and the North Central region, a lot more bears are being seen. The problem with bears in Florida is that they're in these subpopulations. And we have genetic information that shows us that they've experienced some pretty significant bottlenecks, including Chasowitska. And so having these disparate populations led us to lots of subpopulation studies. So they've done a lot of individual studies on small bear populations, but not a all-inclusive study of the entire state. So what did we do? Well, I didn't go with collar bears in Florida, but we've been doing it for almost 40 years. And so we were able to get 40 years worth of data, but then you can't use all that data. So we had to go through a process to say, okay, what data is usable from these animals? They have to be adults. We have to have so many locations. If it's GPS data, it has to be good GPS data, so the dilution of precision has to be less than 7. We're not going to use capture mortality locations. And we're going to have to subsample the GPS data to make sure we deal with things like autocorrelation. We ended up with a data set that's pretty unheard of. 86,000 locations of bears that covered 236 species that could be included. Pretty massive, but keeping in mind, bears are very different across the state. I approached the state of Florida. Brian Scheich is the bear biologist for the state, and we said, we can build you a state model, but it's going to be very different than if we build you a model based on bear management units. So a much more specific area that they're managing each individual population. And he said, well, by all means, do more than what we had said you need to do. So 2 methods we came up with, because when Aaron and I were in discussions, we knew we were probably going to need to do some kind of modeling average. So we wanted statistical methods that algorithmically looked at the bear locations differently. And so we chose maximum entropy, which is the one Aaron likes, and we chose notice distance, which is the one that Jennifer likes. And they do in fact function quite differently, but they're able to give us almost like a just different mathematical viewpoint of what these bears are likely using. Of course, with all modeling, you have to go through a pretty extensive accuracy assessment, and so we did many because we knew that this was going to be something reviewers and state biologists wanted to see how accurate is it. We looked at area under the curve, we looked at total sensitivity specificity. There's a couple different sensitivity specificity metrics, and then we used the continuous voice index, all to gauge how good did our models do through most typically a jackknifing procedure. How good did our models do at predicting where bears would likely be? Okay, so we came up with our method. We came up with how we were going to assess our model. We had to come up with variables. Now, I'm a black bear biologist. That's been my area of expertise for a long time. So I have a really good feel for what we probably needed to include, but Florida is very unique. And so we did an extensive literature search, and we were able to assess all the variables that are likely going to be important to bears. So we built all of those inside of the GIS system. And then we went through a correlation assessment and the modeling procedure. And immediately, many variables were removed. Okay? So the ones that are not X'd out are the variables that we recognize, the model recognized were important. These 5 variables, both models said, yes, we need to have these variables to be able to drive this model of where bears are. Agricultural density, distance to vegetation, primary road density, a shape index, and wetland density. Both models. And then the Halonovus did something a little bit different in that it added 3 more variables that it needed to have. So distance to river, elevation, and distance to forage. And that forage was an expert-driven variable based on a farmer assessment and biologist assessment of forage that bears were typically using. So we come up with 2 models, and this is generally what they look like. The variables are ranked in level of importance, and you can see the plus or minus tells you the relationship with bear habitat. We have our maximum entropy, which is a genetic algorithm on the left, and we have our Halonovus distance statistic, which is a unitless, multidimensional statistics, which is just a number that we then have to manipulate on the right. And it's a measure of dissimilarity, and similarity indices are typically viewed as the primary method to do presence-only habitat modeling of terrestrial species. So we got 2 models, and we went through those rigorous testing, and lo and behold, they did really, really well. And we had done our homework and had worked really hard beforehand, and we're very lucky in that these models performed well. But they're not exactly the same. You can kind of see that. If you look at this kind of teal color, you can see in the panhandle, we don't have as much, and we have much more here. And you can see right here, right in the middle of the central state, you got, oh, this is like prime bear habitat, but it's gone here. And so the models are viewing things a little differently, and this is one of the beauties of model averaging. So now we do something that's a little controversial. Ecologists don't like doing what we had to do. State managers love it, and that is we have to say a yes or no. We're going to take it from a continuous variable, and we're going to make it a binary. This is good, and this is bad. And the ecologists know that's not reality. Bears use habitat, across the spectrum. State managers have to have quantities. They want square kilometers or square miles for them to move forward with their management. And so we did that. There's a method to do it. Maximum entropy has it built in where it can come up with these cutoffs. We can do it with a cumulative frequency distribution for the Halonovus distance. And so we went through this method of coming up with the cutoffs, and then we averaged those together. Again, giving us a categorical variable of, not good to okay to pretty good. Right? I'm going to show you that in its binary format. So we came up with a state level model, 45,000, almost 46,000 square kilometers of where we're going to say there's high quality bear habitat. But remember, this is across the whole state. So this is a very general model for bear habitat, right? Well, I had told Brian, look, we need a more specific model as well. He said, yes, let's do the BMU model. This is that same process, but now instead of doing the model across the entirety, I did individual models for each bear management unit and then mosaic them together, right? And I'm going to show you the binary of the BMU. Now we're down to 24,000. So in my mind as the bear ecologist, this is incredibly good, high quality, specific bear habitat in each bear management unit. Versus the state model, which is like, this is much more general bear habitat across the state, right, for comparison purposes. So then we did a bunch of quantification of how much habitat this actually was, splitting it into the specific BMUs, looking at how much is how much is actual habitat, comparing it to the state, trying to start to identify where are problem areas. Big Bend is a problem because there's bears there, but there's really essentially no habitat whatsoever, okay? And we knew that. In fact, it's one of the areas they have some genetic issues. And so we're basically showing them quantitatively what they're seeing on the ground. We then went through the next step that went into a publication that's already out, and we said, okay, we have a really good model. The state agrees and has signed off on it. We feel really good about it. Let's throw some things in terms of predictions at it. So let's look at the climate predictions of sea level rise out to 2100, coming out of NOAA's predictions. And we did a best and worst case scenario. And in general, worst case scenario, 10% of quality bear habitat would be inundated at the state level, 14% at the BMU level by 2100. Then we went, and the state of Florida is quite advanced in some of their GIS capabilities. And they've done an extensive development modeling procedure looking at urban sprawl. And they did it out to, what are we looking at by 2070? And so we applied some of their metrics to what we see as habitat quality data right now, quality habitat right now. And how much are we going to lose based on just development on their projections? Best and worst case scenario. Worst case scenario, 16% of the state will be lost, 7% of the BMU will be lost. And then the last thing we did was they asked us to quantify protected and unprotected habitat, because we know that the state has better control, state and federal lands, in terms of how they want to manage it. And lo and behold, 54% of the state is unprotected. So half of what the state has as far as quality bear habitat is not protected. Only 15% at the BMU level is unprotected. And this is very interesting because remember I said we have an expanding bear population. And it backed up our models because the BMU model is really the heart of the quality bear habitat, and their sources, they're pumping out bears, right? Whereas the state model is much more general. And so this made perfect sense logically, and the state of Florida was very interested in these results. And we went ahead and published this piece. There's 2 or 3 publications we're still working on, but we went ahead and published this piece that was just the consensus model and looking at how to prioritize based on sea level rise, based on urban sprawl, and based on protected status. Okay, so what's next? Next, what they were really interested in the project I had done in Louisiana and Arkansas, is Louisiana and most of Arkansas have really high quality LiDAR data. And if you have really high quality full point cloud LiDAR data, you can quantify metrics of the forest remotely. And so they're like, oh, can we do this for Florida? I said, well, I had all that data for free, and so we'll try to do it. Because they wanted to understand how big were our trees, how much can we cover, what's the DBH, what's the understory look like. They were specifically interested in saw palmetto, which is a huge, important food source for bears throughout the state, in the shrub layer, which is really hard to get at. And so we entered the second portion of this project. And we did this as opposed to the model that was really focused on the state level. We did it at the state and BMU level, and then we looked across their current occupancy categories. So the state had occupancy categories from rare to frequent, and they keep up with these maps on a pretty regular basis. So we started looking at a lot of pieces of information. We looked at, okay, what land cover occurs where, what do we know about all of the things that are happening in terms of the landscape? How much agriculture is there? Who owns that agriculture? What are the top crops? And specifically dove into forest data. FIA data, forest inventory analysis. There's a federal FIA program that monitors trees across the United States on private plots, and the state of Florida happens to have their own separate FIA data. And so we dove into that FIA data. I found out where their plots were, and plots that fell within high quality bear habitat, we did a deep dive into what do those trees look like. We also looked at a fire data set for high quality habitat. How often is it being burned? How does the burn potentially impact bear habitat? And then we looked at the true FIA data, and this data comes out of actually Knoxville, Tennessee. You have to send them your spatial file and then sign away your firstborn child, and then they send you back all of the data that happened to fall within that shapefile you sent them, because it is so protected. Where these plots are, you don't know the true location, you just know it fell somewhere within your shapefile. So we're limited in the spatially explicit aspect of this, and we're in the Excel, like literally thousands of Excel table world, but it has such amazing information that it would not be possible for me as a researcher to go out and do in a single project. And then within this, we looked at tree species, DBH height, but also percent hard mass. We were interested in that for the bears, meaning acorn bearing species. Now, I'm not going to go through all of these results, but I'm going to give you a few, give you some idea of the quantity of data and the type of data. In the panhandle, pretty decent habitat, not the most, Central have the most, but pretty decent habitat. And in there, frequently I have bears and rarely do I have bears categories. These are the top 3 most sampled tree species. You should see really quickly, this is likely a very specific kind of habitat, likely fire dependent. Okay, we'll come back to that. And then I can see the average DBH and the average height. And I'm looking at the percent oak. How much oak do we have? Because I'm interested in that. And what is the DBH of the oak? Why would I care? The DBH of an oak tree is going to give you a general indication of is it producing acorns. Of course, the length or the width of the canopy is the pinnacle of that, right? And what this immediately tells me is these are really small, scrubby sad oaks. And they might want them that way. That might be okay because of the kind of habitat it is. But if you were just being driven by your need for bears, this is a problem, right? We'll come back to that. When you move across the board outside of the frequently occupied, okay, so I'm only talking about occasional and rare, right? When you moved outside of that, across the state, oak diameters were restricted. They were not within what we would have considered average, okay? And I recognize, so I said expected, but these are not all bottomland hardwood, right? These are mostly moral pine savanna type ecosystems, sandhill type ecosystems. So this isn't totally unexpected, but it's worth noting that we're not doing bumper crops of acorns. So we're not producing tons of bear food. We also noticed a very small percentage of oak in all of the northern BMUs. So that's across the panhandle and in that northernmost BMU. Again, I wasn't super surprised because many of these are longleaf ecosystems. They are specifically managing them for longleaf, which means they are consistently burning them. They don't want lots of oak, okay? Now we're going to quickly move into conflicting conservation objectives, okay? The other thing that I noticed throughout the state is that specifically red and white oak, outside of the northern longleaf systems, were just barely within the normal range of size. And now I don't know the age at this point, I don't know the rotation, and so this could be an aging forest, which we see across much of North America. The forests that are left intact are aging. But I don't know that information, but it is relevant to what I tell the state as I walk away from that. And so I gave them some recommendations, and we'll see some more of this on the next slide, I believe, but I said you need to know and adjust your recommendation of what you expect for bears based on if it's a fire-based ecosystem. Are these younger forests? Because if they are, there's some things that you might want to plan for, like your carrying capacity is going to quickly be increasing over the next 20 years, and you're already having problems now. And then if they aren't, and you have an objective just to better support bears, you probably need to start thinking about pre-thinning. You need to get rid of some trees and allow crowns to grow and allow diameters to grow. If that's not your objective, then that might not be something you're concerned about. Brian followed up with, okay, we have density estimates for bear populations throughout the state. There's like dozens of studies that have been done on each of these individual populations. They're typically referred to as seeker study areas, that's spatially explicit capture-recapture studies. They come up with a true abundance estimate or density of bears. And he said, can we go and just, let's hypothetically apply the nearest density that we have to a big patch of habitat that's unoccupied and see how many more we can support, because we have too many bears right now. Bears are coming everywhere. And I was like, sure, we can do that. So we looked at patches that were bigger than 50 square kilometers. I give you this 0.5 buffer because I do this inside of GIS. So any patch within 0.5 kilometers counts as one functional patch because bears move, and roads will bisect and what have you. I'll show you a picture of this in just a second. In the state model, we identified 68 functional patches that could support bears that had no actual abundance estimate as it stood. Now this is kind of messy, so I'm just going to have you key in on what we're talking about. Anything in the black is an area that has an abundance estimate. Any actual colored patch is a functional patch at the state level. So this has more than 50 square kilometers of quality habitat, no bear estimate. Okay. Up close, looks more like this. I'm pointing out the 0.5 because you see, it's not necessarily still biological, right? This is just a little bit more than 0.5 that separate it. Yet this is probably still one functional patch. We have to start somewhere. So this is how we did this. We also did it at the BMU level just to get a better idea of what was going on. And I wanted to flip back and forth between these, and you'll see this gray spot right here, it stays the same, right? These two models, though, gave us very different functional patches. Again, another reason model averaging is important. So what do? We figure all these out at the state level. We apply the closest seeker density estimate. We had a rule set for how that was applied, and we came up with, you currently have 3,000 bears in the state of Florida that are your threatened Florida black bear. Right now, we're saying you have the amount of habitat to functionally support at least another 1,200 bears. I don't know whether they took that as good news or bad news. It felt like it went both ways. But it made sense to them biologically, and now they had a justification for some of the management regimes that they were interested in implementing. Okay, last subject, corridors and linkages. Aaron had extensively used a program called Linkage Mapper. I knew I wanted to do circuit theory, and the nice thing about Linkage Mapper is a packaged program that creates a least cost path between whatever shapes you're interested in. And then within that path, it can run circuit theory, which finds the least resistance of flow. And so we do that over the framework of the bear habitat. So we use the input from our bear habitat model, and you can see the brown patches are occupied patches and the black patches are unoccupied. And we run it through this program that does a couple of different things. The first thing it does is it figures out, okay, what's the easiest way for me to get from patch A to patch B? That's your least cost path based on the habitat that exists. And then it comes in and it's like, okay, I've got this general path. I'm going to look for specific flow lines. That's the circuit theory. I'm going to look for specific flow lines through that path to figure out where I have pinch points. Pinch points are where the restriction of the movement of the animal is so tight that you've got a problem. This gives you kind of a better picture in terms of coloration of the connectivity. And whenever you start to see the red, you identify, okay, this is a pinch point we're going to have to pay attention to. We need to go in and take a closer look. Now, this next slide is messy. You don't have to really walk away from this, except that I've shown you the top 10 pinch points, and we're going to look at a few of them. We're going to look at we're going to look at the smallest and the largest. Here's your smallest pinch point. So this is the actual satellite footage of what's happening. You can see you've got city, you've probably got a lot of ag, and you've got bears that are likely flowing through here. And then this block is where it's saying, this is all bears have. This is probably too inundated. We're walking up against habitat they're not going to use or want to move through. So here we are. Now, what do you want to do about it? Let's look at the largest. This is at the very southern end of Florida. This is all Everglades. It's too inundated for bears to really move through, although you'd be surprised at what they can. It's bumped up against ag. They're not going to go into there. They're going to get harassed, and it's not secure habitat. And they have the largest pinch point is still this strip of land that just buffers that. This sets us up perfectly to be able to go to a landowner and say, this is what's going on, and we want to put a conservation easement on your property right here. And so these pinch points provide a tremendous amount of information to the state of Florida in terms of where they need to identify management objectives that are very specific to the landscape. The caveat being, we just picked the top 10 big ones. And there are literally a host of ways to prioritize this. genetics can prioritize its size of subpopulation, quality of habitat within them, and that is the next step that we're doing now. So ongoing work has a couple different pieces. The first piece is we're going to do a robust validation of our model in a new and unique way. We've only seen it done a couple ways. We're going to take a new set of data that we have from the Glades Highland population, and it's very fine scale step data of bears literally walking on the landscape. It's fascinating. Step selection functions are a mathematical way to look at how a bear actually moves like this. You have a point of a bear, you have it at hour 1. At hour 2, the bear is here. I can calculate a turning angle from point 1 to 2 and a distance. And over a huge data set of thousands upon thousands of locations, I can create these distributions of turning angles and step lengths as they relate to what was on the landscape. Did they step out of forest into ag? Did they always turn right? Do they turn at a certain degree? Is there a point in time when they turn around? And so mathematically, you're building a distribution for how an individual animal actually moves. So now we're going to build these step selection functions and put them on top of the habitat model as a truth finder. Does our habitat model do a good job of capturing the individual bear and how it moves circuitously through habitat? And so that's what we're actually working on right now with a data set out of this University of Kentucky. I won't pull that. Then we're going to go back into the corridors and we're going to do a much more robust prioritization based on the genetic data that we have, the size and the shape and the quality of habitat. For each pinch point, we're going to come up with a better way for the state to be able to say, this is worth my dollars versus this, right? So a cost-benefit analysis of where they should spend their time managing these corridors and pinch points. If I have time and inclination, there's a lot of forest inventory analysis data that we haven't really been able to spend enough time on. I think there's a lot more that we could get out of that. At the same time, the state of Florida is currently planning to have a full LiDAR data set available in 23, and I know that they want to be able to use that to try and assess saw palmetto specifically. In general, I walked away from the state and I gave them the recommendation that they just need more microhabitat variables. They need to go in and do vegetative sampling with bears in mind. They're an umbrella species, we protect them, we protect numerous species that use that same land underneath them. So conclusion. Fire-dependent ecosystems, they need to sit down at the table and understand where they're managing for what and what is the conservation goal. Understanding the dominance of trees, the crown size and spacing for oak species is really important. I had suggested they could extend rotations or support people extending rotations and possibly pre-thinning if this is in fact, the oaks just have not been able to be released in these ecosystems, and that's something that would be desired. In terms of rotation, I don't know what the actual age structure of the FIA data is because they don't core those trees. But what I do know is if it's a young forest, the oak component is young, then in 10 to 20 years, based on the DBH that we see right now, you're going to have pretty significant increase in hard mass, which correlates perfectly with increases in bears. We already know that. We've established it for the last 40 years. So they're already frustrated because they have bears that they would like to place somewhere else that are becoming nuisance problems, and it's likely that that's probably only going to increase. And so I did say we probably want to adjust the densities that you expect in the panhandle based on the longleaf ecosystem, and that again made a lot of sense to them. Eglin Air Force Base is a perfect example. They are consistently shocked with why they don't have more bears there, and the habitat's telling them why they don't. Generally, they're doing well. Their range is expanding. There's a ton of quality habitat in areas where there are no bears. There's a lot of corridors that need thought in terms of long-term maintenance for the genetic viability. The Chazawitzka population only has 20 to 30 bears, and it's already been shown to be a complete bottleneck for those bears. And so we were able to provide them some really specific points of where they need to concentrate their management efforts. And then we had long conversations with them about we may start to see different management goals based on the specific BMU. There's been a huge push to hunt bears in Florida for a long time, and that's only getting stronger as bears increase. And the state is interested in having scientific justification. This is kind of the first step in terms of some BMUs we're going to have to conserve, other BMUs could be evaluated for potentially hunting. And my last ditch plug, it was some kind of structured decision making. Mitch just sat through my class with that. In terms of, we have to manage at the ecosystem level when it comes to a place like Florida, because there's so many competing needs. Okay, last thing. This was a very different project, and it was a labor of love for Erin. She did an amazing job, but I knew that this was not going to be a situation like I had been in before, where the state would come back to me and say, hey, can you rerun this with the new land cover NLCD you just put out, or what have you. And so we did it a little differently, and we created a product for them and a workflow, because they have a fully operational, bigger than mine GIS component to the Fish and Wildlife Conservation Commission staff. And so we sat down and did a training with them. And we did a workflow, and we gave them all of the R code, and we gave them the packages, and we gave them the way we built the variables, so that their in-house staff would be able to, the next time a land cover comes open, rerun our model and have something to exactly compare to what we've done. And this is a weakness I've seen in the wildlife world, where it's like, oh, I'm going to do the next best thing instead of doing what has been done well and having something to compare it to. And so they were super excited, and so were we, to be able to run this workshop and help them recreate the specific deliverables that we provided to them. And the ending that I would say of this is very, very rarely am I like, oh, I'm so proud of what I've done. I'm proud of my graduate students all the time. I'm proud of my kids, but that's just not normally in my nature. And Brian sent me an email, I don't know, 2 or 3 weeks ago, because he was like, hey, let's see if we can get some more money for corridors. I was like, I like money. And then as a little aside in his email, he said, just so you know, we fully incorporated your habitat models in all of our plans across all the Fish and Wildlife Conservation Committee, and sent them to Florida Department of Transportation. So everybody's using this. And it was really powerful for me. It's like, wow. And I called her, and I was like, oh my gosh, can you believe this? And she's like, I don't know whether to be petrified or super excited or both. But it's science that's actually been done well and is being used and managed right now. So we're really proud of it. And with that, I'm happy to take any questions that you have.